Many of you have sent me your answer to the practice card test on keys, and from this I identify some of the common errors that you guys have made, and one of them is this question about primitive root. Okay? And there are 5 basic facts that I mentioned in my tutorial that you need to learn by heart about primitive root. They are what, they are how one, they are when, how many, and how part 2. Okay? If you don't know what they are, please refer to my tutorial notes last time. Let's look at this question. Which of the following statement is true? Statement number A, 4 is a primitive root modulo 7 to the n for all positive integer n. Of course, you can check by using the method that I introduced last time by checking whether 4 is a primitive root modulo 49 and then to deduce whether it's a primitive root modulo all the powers of 7. But a faster way to do it is the following. A is indeed false. The reason why I can tell immediately because 4 is a square number. In particular, 4 is 2 squared. Why being a square number is a problem? Let's look at this. If I take 4 to the power 549 over 2, okay, then what do I have? Because 4 is a square number, so this is 2 squared, 549 over 2, and then 2 to the 549. Okay, but what is this modulo 49? We know that by Euler's theorem, 2 to the 549 common to 1. Okay? Therefore, what do we have? We have 4 to the power 549 over 2 common to 1 modulo 49. That means that the order of 4 is at most 549 over 2, which is strictly less than 549. So therefore, 4 is not a primitive root. Mod 49. Okay. Indeed, this argument will work for any square number. Therefore, we have a slogan. The slogan is square number are not primitive root. Indeed, in 2 weeks' time, we will prove something stronger than this. We will show that all the quadratic residue, whatever they are not primitive root. But we'll leave it 2 weeks later. Okay? So, statement A is incorrect. Okay, let's look at statement B. There are 4 primitive root modulo 15. Is that correct? You remember the statement, right? The statement how many in my tutorial that says that there are 5n primitive root modulo n. Is that correct? Wrong. Okay, because not every single integer n has a primitive root. Okay, so the correct statement is for n equals to 1, 2, 4, p to the n, 2 times p to the, okay, this is a poor notation, p to the m, 2 times p to the m, where p is all prime. Only for integer that look like this, we have a primitive root, and we have 5n number of primitive root. 15 is not of this form, any of this form. Therefore, there are no primitive root, 0 primitive root modulo 15. Okay? So, statement B is also incorrect. And the statement C, now 27 is the power of all primes, so primitive root exists, and the number of primitive root equals to 527. Okay, and I leave that as an exercise. This is find of 27 minus 9, so you have 18, and then this is we define 2, find 9, So this is 6. So there's 6 primitive roots. So statement C is correct. Okay. Although we have identified the answer already, but let us look at statement D anyway. It says that 2 is a primitive root modulo every single odd prime number. This is clearly false, okay? Because we mentioned a trick in the tutorial, right? That says that, so this is a trick that I mentioned in the tutorial. That is, if P is congruent to plus or minus 1 mod 8, P is a prime that congruent to plus or minus 1 mod 8, then 2 is not a primitive root. Mod P. Okay, so for example, 2 is not a primitive root modulo 17, because 17 congruent to 1 mod 8. Okay, the reason why this trick works, again, we'll prove it in 2 weeks time, but for the moment, it's good to bear in mind. So I hope this video is useful. Let me know what you think, and then let me know if you have any other questions. Thank you.